and welcome to this video where I'll be showcasing and guiding you through how you can take one DEEPCRAFT Studio Accelerator and adding additional data and moving that towards a more ready product for your actual application area. As you know, in our DEEPCRAFT AI Hub, we have plenty of these DEEPCRAFT Studio Accelerators that act as starting points for your products and that you can use integrated into DEEPCRAFT Studio to start your own machine learning process. Let's start by having a look at what we can see in the AI Hub. If we go down and sort, we can sort by all the different models that we can use for development. And looking through these, we see that we have a myriad of different sensors and use cases that we support for the DEEPCRAFT Studio Accelerators. And these are also available in the software. So let's go over there and have a bit of a look and see what we can do with them. Here we have the DEEPCRAFT Studio software, and we can go in and create a new project here. And let's select one that we can more easily add some more data to and even add a completely new class. Under the tab Studio Accelerators, we can find the ones for example, an IMU, which is the accelerometer and gyroscope. We also have ones for microphones, capacitive sensing, electrical signals, and for object detection camera. Today, I will be using this PSOC Edge E84 AI evaluation kit, which has a lot of different sensors. You can see them on the right side of my screen here, all of the sensors that are supported in this kit. So let's select one of those. I could also do one for camera, for example, although I would need to attach a camera to take those photos with. So let's see what we can do here with the IMU. We have, for example, the movement type detection project. And by selecting this, we can also start downloading the data of this. So let's begin that process. Currently, what this project does, is that it detects, using the accelerometer of the board, what types of motion are being done. And the ones that are supported by default to this are shaking, which is an erratic motion, also circle, which is a more steady motion, and then just a stationary board. But what if we wanted to, for example, add more knowledge and more classes to this model? Well, that's what I'll be showing you today. So in order to start the data collection, you will need to have what's called a data collection firmware running on your PSOC Edge kit. And you can do this through Modus Toolbox and just flash the data collection firmware. Once you have that flashed, you can get into the GraphUX interface in DEEPCRAFT Studio. From the welcome page, you can simply navigate to the GraphUX tab when you can make new projects, and just creating an empty project will get you to a blank canvas essentially. And from this blank canvas, you can pull in nodes from the right side here in the Node Explorer, including all the different sensors that are on the board. So for example, for this project, the IMU, we can just drag that in. And by adding a data track and connecting these two together, we can collect the data for this. And we can see here we have a 2x3 matrix collected at 50 Hertz. That is the 3 different axes of the accelerometer and the 3 different axes of the gyroscope being collected. By clicking on the node and going into its properties, we can change some of the different parameters here. And let's have a look at the movement type detection to make sure that we're aligned with what we're doing there. So here we have on the screen the movement type detection project. And we can see that we have about 49 different sessions of data that have been collected into this for the different classes of circle and shaking. There is also the unlabeled data, which is essentially when the board is stationary. And we can see that this is being collected, as I had in the previous tab, at 2x3, and then also collected at 50 Hertz. So we can see that the default parameters that we get when we drag out the node suit us well if we wanted to add an additional class. So we also have the README that comes accompanying with any of the DEEPCRAFT Studio Accelerators, which you can use to get an overview of how the data was collected. This also highlights the different settings that were used for collecting the data for the board, as well as providing a guide here on how to add more data. And you can see that the setup that we have is identical to what I just created in the GraphUX, with the addition of a predefined labels. So let's go over and add that in. If we go back into the GraphUX, we can go under Annotation and drag out a predefined labels tab. And here we could add in circle, shaking, But let's add another one, which is the purpose of this explanation after all. Let's add pivoting, which is, for example, when I'm moving the board in a side-to-side motion, so not quite shaking, not quite circling, but something completely different, which could be interesting to see. And you can use this as an example for how you might be able to add your own new classes into DEEPCRAFT Studio as a project. But if we continue going through the README, there is a bit of an explanation about how the labeling works, which is what I'll show you shortly, as well as some steps to production that you can use for the Studio Accelerators. Now, let's go through and actually do some of the data collection. We have everything we need here on the screen. It is the graph UX, so by simply hitting the play button at the top, we will generate a timeline and start the recording. And by hitting on the play button here, we can see that the sensor that we had in the graph, the IMU, is being collected here. And if I start moving the board up and down, we can see that it moves as expected, and then over back and forth motion, we see a different color going up and down. And if I pivot it left to right, we see that it's acting as expected there. Now, let's actually do some labeling of this while it's going. So if I restart the recording, then at the start, it's just going to be still, stationary, and then that will mean that nothing is being recorded. But if I start moving it up and down, I can click on the shaking button here at the top, and we can add that label. And then I can also click on the shaking button in order to swap over to pivoting, and I move it left to right. So this will add a new type of class into our data set. Now, as you might have seen, I did not perform that perfectly with the intersections of when the label started and began, but you can, once you've done the recording, you can just go through and easily pivot these labels to actually create the optimal space. And now, if I hit on Control S to this labeled data set, I can save this data into my project, and then I can upload that. So let's collect some more data, and I'll be back when I have some more data to record and add into the project. So here we can see the board in a more close-up angle. Let's start a new data recording so that we can see a bit more what's going on. So starting up the recording again, we can see that we can, once again have the data, and let's start pivoting the board back and forth. You might notice that I didn't click the button now instantly, and that's fine. I can add labels in post, and in fact I can even click it on now and just change the starting point of it later. Say either you can do the adding of labels during the recording, or you can do it in post. Let's pivot it in another angle. We want to make sure we capture as much different situations of the data as possible in order to make a model that is more solid. If we wanted to only have a model that captures left to right pivoting, then we could of course do that, but it's better to have a model that is more general. Let's start moving it up and down as well. In general, we want to have a balance between our classes, and we had around 19 minutes of data for the other classes, so we would be here a while, but in all, about 20 minutes of data collection is not too much to bear, although I will spare you the hassle of watching me move a board around for 20 minutes. So once we are done with happy with our data recording, we can once again pivot the label so that we have it covering our entire data collection here. And then we can hit Control S again and save this data. Now, for the adding of data, we can just go into the movement type detection and click on the bottom left here where we have Add Data. Now, here we can navigate to where we actually recorded this data and select the two sessions that we recorded, or rather the project that contains them, and we see the IMU data and the live labels have been appearing on screen. And we can click through this and see that our session count is now increased from 49 to 50, and we also have a new class added to the project, pivoting, which we see we have about 1 minute of data for. So let me collect some more data, and I can get back to you once we have a model ready to train. And now, as you can see, I've recorded some additional sessions with the pivoting data, and in the project we have about 8 minutes of that data added. So with that, how can we go about the rest of the project beyond the data? We need to allocate this data into an appropriate data set, and it will be by default into the unassigned data set. We can do this by going into the Redistribute Sets button, and here at the top we can select the scope to redistribute data only from the unassigned set, and then select the distribution that we want. I'm going to be showcasing you a evaluation and testing live on the device, so I will be putting almost all the data into the actual train data set. So by clicking on Redistribute, we will get that data into our new data allocated into those sets. We will be using the same pre-processing for the project as it is in the default mode. That is a sliding window with 2-second length and giving a prediction every 5 seconds. Still seems appropriate to having added pivoting. As for the training tab, here we will need to generate new models because the output shape will be different than what is already defined. We will be having 4 output classes instead of 3. And that can easily be done by going into Generate Model List and clicking again. You can change some of these settings. I will stick to medium and balanced as we had in the previous one, but if you have a different hardware setup, for example on the PSOC Edge E84, you can easily run a large model if you want. But selecting those settings, we now have a project setup where we can start training with this new data. So going in and clicking on Start New Training Job, we can start a training for movement type detection. And now we have the additional class involved. This is going to start up the training job, and it's going to prompt us if we want to open that job, and we can do so. In the meantime, I have a separate project that was an identical training of the model already running, so we can jump straight to seeing the final results of a trained model as well. We have here the 4 different model files of the one I already trained. Now we have the prompt opening up, so for the training of the one that I just triggered. Here are the already trained models that have completed a training. I don't recommend looking at the test statistics of these models we trained because, as I mentioned, I put almost all of the data into the training data set and not into validation or testing. So looking at these metrics, which we do provide for the different models, we can see that it is performing quite well, but we have a very limited sample size from this. So I would not recommend looking at it. We can go and navigate to actually download these models and test them in a real-time scenario instead, which will be much more believable. So navigating over to the right, we can download these model files very easily, and that will be able to then be used for evaluation in DEEPCRAFT Studio. So going in and downloading this data files, we can navigate to the models folder, and we can override the models that we already have there. This will create the download, and then we can easily go and back to our GraphUX where we can perform the actual evaluation. If we navigate to this models folder where we just downloaded them, we can see that we have the .h5 file here, and we can just drag this out into the graph here and connect the IMU straight to it. This is going to feed the data into the preprocessor and then the model, and then we can drag out a label track and then connect that as well. So doing this will effectively collect the IMU data, display it to us in this top data track, then run it through the model, and then using the label track, we will get predictions from this for the labels. So let's click on play here and see if it performs as expected with detecting the pivoting as well. We can start this up, and we can see that the labels will be generated at the bottom here. So if I pick up the board and just start by shaking it a bit, we see that a label appears at the bottom. Then I can start doing the pivoting motion instead, which we added data to. And I can even try it in 2 different axes. And then I can do the shaking again. And then let's do some more pivoting. Now let's have a look at what exactly happened there. We can see the pivoting at the end was detected as pivoting. We can see that the shaking was detected as shaking. We can see that there is multiple different pivots going on here in the transition because I was doing pivoting in some different axes, but all of them were labeled as pivoting, but with different confidence values, and we can sort of get an understanding of where the model doesn't really feel confident here. It seems that the original axis I did for pivoting left to right was slightly less confidence level than the pivoting for the other directions. And the original shaking I did was predicted as high confidence level shaking. We do still have a lot more shaking data than pivoting data into this model, so that sort of makes sense. It seems to work pretty well here, but this is, as a reminder, running in DEEPCRAFT Studio using the processing power of your local environment, not on the device. but we can very easily set up that environment to test how it would work on the device. And doing so would require us to just double click on the model here on the left side, which is the downloaded model, a TensorFlow model, and by double clicking on it, we can open it up and have an overview over it. We can see once again what the preprocessor and the model parameters are and how it performed on the test evaluation. But finally, we can go into the code generation, and here we can easily define what model what hardware we want to deploy it on. In my case, it is the PSOC Edge E84 AI evaluation kit, which would require us going into defining an architecture being Infineon PSOC. Then the target device, we want to target it on the high performance, the M55U55 core. Then let's activate some pre-processing acceleration to make sure that the optimizations are being done. And then we also need to quantize the model. For running it on the U55, we do only support quantized models right now. So let's do a quantization, and that requires us to select some data in order to use that as a baseline for the quantization. And we can easily just navigate to the movements type detection folder, which is the data that we used to train the model, and select that. And then we can do some different definitions for the actual U55, but I will just keep it to the defaults here. And then we can click on Generate Code. And this is going to generate the C code for us that we can then use in Modus Toolbox. If we get over to Modus Toolbox, we can utilize what is called the PSOC Edge Machine Learning DeepCraft Deploy Motion code example. And this one you can easily download for yourselves by going into New Application and then selecting the appropriate kit that you're using, in this case the PSOC Edge AI evaluation kit. Going through that, you can then select a lot of different machine learning code examples here, and the one that we want to use is the DeepCraft Deploy Motion. So you can simply select this one and create that project. I have mine created here already, and you can very easily insert your own model that you've defined in DeepCraft Studio here. And the one place you would go do that is in this file here, which is the CM55 for the U55 core. And in here we have the model files, model.c and model.h. By now, I hope that the code generation is done in Studio, and which it is. We can see that because we have a performance and validation report here on our screen, highlighting to us how much memory the model is taking up, as well as how many NPU cycles it's running at. We can see that relative to the power of the PSOC Edge, this is a very small model. I could have easily gone with large instead of just medium, but we will keep this as the same as we had for the default project, and we can do that to perform a bit of a comparison. In the Infineon folder here, we see that we have now generated a model.c and a model.h file. And by just copy pasting these into the Modus Toolbox here, we can override these model.c and model.h files. So let's navigate to those defined ones. In Studio Projects, we have the movement type detection, models, Infineon, and here's model.c, model.h. We can just move those over into this one and override these files. Now we have a project ready to deploy with the different model defined. And we would have to build the application and then launch it. I've already built mine, so let's connect our board to the port required, the KitProg3 port for flashing, and then let's program the board. And after this, we can just open a serial terminal, and from there we can see the results of the model running on the board on the silicon in real time. Hopefully this shouldn't take too long. The recommended serial terminal that we use, you can use the built-in one in Modus Toolbox, but I will be using TerraTerm here, and it can connect to the correct port. You will also need to set up the serial terminal and select a rate speed of 115,200. And with these settings, we should be able to see that the deployment has now done. And we see the results on screen. It's currently unlabeled because the board is stationary. If I start pivoting it left to right, we see that the likelihood, confidence level of pivoting goes up quite a lot. And then if we start shaking the board, we see that shaking goes up very high. We can pivot it also in a different plane. We see that that confidence level is now above 70, about 90. And we can also move it in a circle, and we see that that one goes up to the highest. So we see that the performance is doing well here as well. And that's the final step. Now I've shown you all the different ways and the steps requisite that you could do to get a new class into a DEEPCRAFT Studio Accelerator. This was a very simple project. I did it in, only about an hour, and that included a decent amount of sitting and shaking the board to collect the data. But hopefully this can serve as a baseline for your understanding in how you can take a project, that is already existing and apply it and adapt it to your own use case. You can add data to a whole host of these different DEEPCRAFT Studio accelerators that we have. We have many ones for audio, we have accelerometer, and those are the ones well supported by the board. But even for the ones that are using electrical signals and such, you can do with exact similar things that I've shown you here today. So hopefully this was a useful video that you could take and use for your knowledge in DEEPCRAFT Studio. So thank you for your attention and watching, and good luck on your projects.